Okay, so sum of forces along the y-axis. So there's it. We have the 50 which is pointing downwards. We have force CE which is pointing upwards to be positive. So it will be equal to 0. So we are going to make this one as well. So the 50 will cross the equal to sign to be 50 force CE. So force CE is equal to 50 kilonewton. So it is under tension. So 50 kilonewton will bring your tension sign. It is positive because it is under tension because it is positive. Okay. So from here we can take another joint. So let's take joint E. Let's take joint E. Let's take joint E. So here the angle is 38, 36, sorry, 36.87. So this angle is an alternate angle, so alternate to this one. So we're going to get the same as here, 36.87. And this angle too is opposite to this angle, so we are going to get the same here, 26.87. So we are taking joint E. So joint E, so F B D of joint E. We're going to get something like this. So here you have this force, or this force will be force EC. So you get force EC, and this force will be force ED. So force ED, and here is 80. So 80 kilonewton here, and here is force EB. So force EB, and here is force EF. So force EF will be, here is E, 36.87, 36.87. So 36.87, 36.87. So then from the previous one that we have found, we know that force DE was force DE or force ED, or all of them are the same. So force DE to be negative 88.88. So force DE equal to negative 88.88 kilonewton. We have force force EC or CE to be equal to 50 kilonewton. So force EC to be equal to 50 kilonewton. It is under tension. So there is compression. So we can ignore the sign and just write C here. So C meaning there is negative here. So We are going to find the sum of forces along the horizontal axis. So sum sigma f of s will be equal to 0. So we have this one. It is on the horizontal axis, so, and it is pointing to the left side, which is going to give us negative f force E F, and we have 80, which is pointing to the right, so plus 80. And from here we have, for every inclined force, it has both horizontal component and vertical component. So let's find its horizontal component. So we are going to get something like this. So here, let's take here to A and here B. So for the horizontal component of this inclined force, we are going to deal with 8 adjacent. 8 adjacent is from here to here, and 8 hypotenuse, which is force EB. So let's bring our so okay, to so from Asuka to we are here, we are dealing with the adjacent and the hypotenuse. So adjacent and hypotenuse, AH, so which is under okay. So cos theta will be equal to adjacent over hypotenuse. So what is the adjacent? Adjacent is A. So cos theta will be equal to A. What is it? Hypotenuse. Force EB. So force EB. So we are making A the sum there. So this time this A will be equal to this time this. So F E B cos theta. So, and it is pointing to the left, so it will be negative. So negative F E B cos theta. Yeah, and we also have this inclined force. So it also have both horizontal component and vertical component. So we are dealing with the horizontal component of this inclined force. So let's assume here to be C and D. So C is the adjacent. So adjacent, we are going to deal with the adjacent and the hypotenuse. So adjacent and hypotenuse will be also K. So we are going to get cos theta adjacent over hypotenuse. What is it adjacent? It adjacent is C. So cos theta will be equal to C. Hypotenuse is F force ED. So force ED. So it is pointing to the left. It is pointing to the right, sorry. So this is sign convention. Y negative, S positive, Y positive, S negative. So it is pointing to the positive direction. We are going to get, so here C will be equal to F force ED cos theta. So force ED, and it is positive, plus force ED cos theta equal to 0. So from here we know, okay, we know only force DE, so we can resolve it. So let's take the sum of forces along the vertical axis. So sum of forces, or sigma of f of y equal to 0. So we have this one, which is force F E C, force EC, force EC, and it is pointing downwards, which is negative. So for every inclined forces, it has both horizontal component and vertical component. So we are going to deal with its vertical component. So we're going to get B, going to deal with the B, which is the opposite, and the hypotenuse, which is force AB. So it will be opposite and hypotenuse. So opposite and hypotenuse will find that so which is sine theta opposite over hypotenuse. So we're going to get sine theta opposite over hypotenuse. So what is the opposite? So the opposite is B. Sorry, the opposite is B. Then the hypotenuse is force EB. Sine theta opposite is B, and opposite is B, and its hypotenuse is force EB. So we are making B the subject. So we are going to get B will be equal to force EB sine theta. And here it is pointing downwards, so it is pointing like this. So we are going to get it as negative. So we can bring it as negative force EB sine theta. Okay, so for this inclined force also, it has both horizontal component and vertical component. So let's deal with its vertical component. I'm going to take D, force D, and force D. We are going to deal with D, which is the opposite, and the hypotenuse, which is FD. So opposite and hypotenuse, it will form that. So opposite and hypotenuse. So I'm going to get, so means sine theta equal to opposite over hypotenuse. So sine theta will be equal to opposite over hypotenuse. So the opposite was D. The opposite was D. The hypotenuse is force DE. So you're going to get sine theta, opposite is D, force, you're going to get force ED. So let's make D the sum. D will be equal to force ED sine theta. So we are going to substitute it into the equation, and it is pointing downwards, so it will be negative. So negative force ED sine theta equal to 0. So from here we know force ED to be negative 88.88. So, and we know force EC to be 50. So we can substitute them into the equation to solve for force EB. So